This video is looking at the 2018 ordinary level question 5, which is transformation geometry. We're given the logo for a cloud key, so it's based on a circle with a few notches cut out of it. And part A of this question is to draw the given logo and then locate points A, A1, A2 and A3. So that's, I've drawn A, A1, A2 and A3. I've done that much. And O as shown, so point O here then as well. Finally, to find the image the image of the given logo under the following transformation. So from A to A1, so from here to here is a translation. From A1 to A2 as an axial symmetry with this red line LL1 as the axis. And then part 3 is A2 to A3 as a central symmetry with point O here as the center of symmetry. All geometric constructions must be clearly shown on your drawing, so you need to show how you created each piece. I've started the setup for this here. It's a circle. Its diameter 60, radius 30. The inner one then is going to be a radius 15, diameter 30. That's given at the bottom of the question. That 30 millimeters down there goes across both circles. Sorry, goes across that smaller circle. So that gives us that much. Solid line down here across the base, and then it's a vertical line from the center and inclined here at this angle. And then there's one other piece here which is 10 millimeters, so that's 5 above and below point A. Here gives us this point. And I'm just going to darken in the remainder of these circles, these arcs. So it's important to distinguish between what's construction line and what is part of the object. So you should go back over and darken in the outlines. So that's our object drawn. The next part of this is then looking at A to A1. So from A here to A1 down here, and that is being done as a translation. There's quite a few points here that we need to move. So we'll take point B here, that's the center point. C, D, we need that one. This point we should be okay with. We'll have a couple of dimensions. This point here we'll need. This one will join B to C, so we won't need to find that where it breaks through the circle. E will give us the radius. F, G, H and I. So quite a few points. Going to take each point in turn. Okay, so A to A1, they've moved this distance and this direction. All other points are going to move the same distance, same direction. So taking your compass, measure the distance from A to A1. And then we're going to mark each point then, same distance, same direction. So this becomes B1. Point down underneath this here, it's on the same line, that's E1. C and D are treated the same way, so point C and D. So point, same distance, same direction. So I've just set up my compass once, and all points are moving same distance, same direction. Finally, G, H and I and F, all of those need to be done as well. Same distance, same direction. So from H, I, G and F. That gives us lots of points here. So this is F1, G1, H1 and I1. So with that much of it drawn, now we can just draw in our circles. B is the center of the arc. So B to C here That's our radius. So this goes all the way around and touches off H. And also travels from D to I, so copying the pattern as it is in the original, D to I there. D joins to C, D joins to C. Almost there. Final part of it then is point of our compass here in the center and measuring from G, F or E, all are the same radius. And again, B joins to D and C joins to B here as well. So that's solid bit. I darken in this little bit here by mistake. I'm just going to lighten that up. Not get rid of it totally, just enough so that we can see what it is. So that's our that's the first part, part B, so it's a translation from A to A1. All lines move the same distance and direction as A to A1. So it's this distance from each individual point, and all lines have gone parallel to each other. Second one of these is A1 to A2. It's an axial symmetry from L to L1, or across L1. That's this line here. Perpendicular to our axis, all points are going to move. So I'm just going to extend the axis line down a little bit further, as some of them are down here and they wouldn't go across it otherwise. So A to A1, so the distance from A to the axis is the same as the axis to A2. Same thing applies for B. Okay, so this time measuring from the axis to the point, so point B here, same distance on the other side. This is B2. Same thing, let's say now for E. So from E to the axis, same distance on the other side. This is E2. So with axial symmetry, it's probably a good idea just to do these all individually. Now, as I say, that C and D are on the same line, so that speeds things up a little bit. So this is D2. And again, from the axis to the point is C2. Now, this is the same from the axis to point G. Same on the other side. This is G2. Now, as F and G are both in line with each other, they're both vertical and their axis is vertical, F should be the same distance away. So we can mark that now just to speed ourselves up a little bit. F2. And then do the same thing from the H's. It's H here. And I should be the same. So that's H2 and I2. So again, we're going to join up our points that we can. C joins to D. F joins to I. G joins to H. And B is going to join to C as a light line to start off with. And then we'll darken that in afterwards. B joins to E. That gives us that part. So drawing in our shape now, point of our compass on the center, which is point B. Pencil here on point E, and it goes from E to F, just like it does in the original. So E to F, and then there's a break, and then from G all the way around until it hits that line coming from C. So that gives us the inner piece, and just darken up that line there. And then finally the outer one, so from B to C, D, or H or I, lots of options there for measuring the radius. So this is from C all the way around to this point over here, which is H. And then from I down to D also. And that's our axial symmetry. So you'll notice here the line from E to the axis, this line here, Same distance from the axis to E on over here then as well. So from E1 to the axis, axis to E2, same distance. Final part of this is our central symmetry with point O here as the center of symmetry. For this one, accuracy, just like the other ones, is really important. Okay, so you're going to join each point from the point, so from point B to the center of symmetry out the other side. So B point, same distance out the other side. It's symmetry, so the distance from the point or center of symmetry to the point, same distance on the other side. And for this, it's probably best to do them in turn. So E So from point O, center of symmetry, to point E, same distance out the other side. That's E3, and this one was B3. Doing the same thing for D. So measuring the point, the distance from O to the point. And same distance out the other side. That's G3. So from point, measure distance from center to the point, same distance out the other side. Starting to get a lot of lines up here, so make sure you're getting these correct. Right one's going to the right spot. I and H pass through point O. Both of them are on the same line as each other. Or they know they're not. Close to it, but not. And I think that's all the points. H3, I3. So I and F join together. And should I do C? No, I did not do C. From O to C. C3. So point of our compass goes on to point B here. Touches I up to D. And then from H all the way around. Back to C. And then same thing in here and further. So from point E to F, and from G all the way around to that line that intersects from B to C. And this line here. So we've done central symmetry now from A2 here up to A3. All points pass through the center of symmetry, same distance out the other side. So that completes this question. That is the 2018 Ordinary Level Question 5 Transformation Geometry.